Have you ever wondered how the universe, with its countless galaxies and stars, came into existence? This question has puzzled humankind for centuries, and while we may not have all the answers, we do have fascinating theories. One of the most widely accepted is the Big Bang theory. Now, don't let the name fool you. The Big Bang wasn't an explosion in the typical sense, but rather a moment of extreme expansion. Imagine, if you will, a tiny dense point, smaller than an atom. Then, in a fraction of a second, it expands, creating space, time, matter, and energy. This rapid, massive expansion is what we refer to as the Big Bang. It's the spark that ignited the creation of everything we see around us today. The galaxies, the stars, even us. So we start our journey with a bang, a Big Bang. From the chaos of the Big Bang, the first stars began to form. In the aftermath of this colossal explosion, the universe was a hot, dense soup of particles. As the universe expanded and cooled down, atoms began to form, primarily hydrogen and helium, the most basic elements in the universe. These atoms clustered together, creating enormous clouds of gas and dust. Here, in these vast cosmic nurseries, the stage was set for the birth of stars. Gravity, the ever-present cosmic sculptor, began to exert its influence. It pulled these particles together, compressing them into increasingly dense pockets. As these pockets grew denser and hotter, the pressure within them increased. Eventually, the pressure became so intense that the atoms within these pockets began to collide. These collisions ignited the process of nuclear fusion, where hydrogen atoms combine to form helium. This fusion process released an incredible amount of energy, lighting up the pocket of gas from the inside, leading to the birth of a new star. A brilliant burning beacon of light, a star had been born from the dust and gas of the cosmos. But a star's life is not eternal. Depending on its size, a star can burn for millions to billions of years. The larger the star, the shorter its lifespan. As a star ages, it exhausts its hydrogen fuel, causing it to expand and cool, turning into a red giant. Eventually, the star's core collapses under its own gravity, triggering a spectacular explosion known as a supernova. This explosion scatters the star's enriched material across the cosmos, dusting the interstellar medium with elements heavier than helium. This stellar debris, imbued with the remnants of a star's life, is then recycled in the birth of new stars, planets, and potentially life. So you see, stars are not just twinkling dots in the night sky. They are cosmic factories, producing and dispersing the building blocks of the universe. These stellar explosions give birth to new stars, continuing the cycle of cosmic life and death. As stars formed and died, they clumped together to form galaxies. These galaxies, vast and magnificent, are not just a handful of stars thrown together. They are colossal families, composed of billions upon billions of stars, all bound together by the powerful force of gravity. Imagine, if you will, a vast sea of gas and dust stretching out into the infinite expanse of space. Over time, regions of this sea begin to condense under the relentless tug of gravity, forming stars. These stars, like celestial fireflies, flicker into existence and gather into clusters. As more stars form and die, they leave behind a mixture of gas and stellar remnants. This cosmic soup, stirred by gravity, begins to swirl and condense, eventually forming a galaxy. These galaxies, like snowflakes in a winter sky, are unique, each one with its own shape and structure. Some are spiral galaxies, like our own Milky Way, with beautiful arms of stars, gas and dust spiraling out from a central bulge. The majestic spirals are home to both young hot stars, which give them their bluish color, and older, cooler stars, which lend a reddish hue. Others are elliptical galaxies, more rounded in shape and often larger than their spiral counterparts. They lack the distinctive spiral arms and are populated mostly by older stars, giving them a more uniform reddish color. And then there are the irregular galaxies. These are the rebels of the universe. They don't conform to the spiral or elliptical shapes. Instead, they have a chaotic structure, often caused by interactions or collisions with other galaxies. So, galaxies are not just collections of stars. They are dynamic, ever-evolving systems where stars are born, live out their lives, and eventually die. They are the cosmic cities where different generations of stars coexist and interact. And within these galaxies, amidst these vast celestial congregations, the stage was set for the next chapter in our cosmic story. Within these galaxies, around these stars, planets began to form. It's an incredible process, really. You see, after a star is born, it leaves behind a swirling mass of gas and dust. This cosmic debris, known as a protoplanetary disk, becomes the building blocks for planets. The process is a bit like the creation of a pearl in an oyster. A tiny grain of sand or a speck of dust triggers the formation, and over time, layer upon layer is added until you have a fully formed planet. The particles within the protoplanetary disk begin to collide and stick together. These collisions result in larger and larger clumps of matter. Over millions of years, these clumps grow into planetesimals, the true progenitors of planets. Some of these planetesimals become the cause of future planets, attracting more matter with their increased gravity. Now let's take a step closer to home. Our own solar system began its journey around 4.6 billion years ago. In the heart of a chaotic cloud of dust and gas, our sun ignited, casting a light on the protoplanetary disk that surrounded it. Over time, the planets we know so well started to form. The inner rocky planets like our Earth formed close to the sun, where the heat of the new star vaporized lighter elements, leaving only heavy materials to form these terrestrial bodies. Further out, the giant gas planets took shape, their massive sizes allowing them to capture lighter gases like hydrogen and helium, which were abundant in the outer reaches of the solar system. The formation of our solar system is a testament to the power and majesty of the universe. A cosmic ballet danced over billions of years. The creation of planets is a process of unimaginable scale and beauty, a testament to the complexity and wonder of our universe. And it's from this cosmic crucible that our home, our Earth, was born. And on one of these planets, life as we know it began to take shape. On our home planet, Earth, life began to evolve. In the vast cosmic theater, Earth's tale is one of transformation. About 4 billion years ago, the first life forms, simple single-celled organisms, emerged from the primordial soup. These microscopic pioneers, not much more than bubbles of genetic material, laid the groundwork for the astonishing variety of life we witness today. Over the eons, these simple creatures began to evolve, driven by the engine of natural selection. The process was slow, painstakingly incremental, but relentless. Over time, these single-celled organisms gave rise to complex, multicellular life. Each leap forward in complexity, a testament to the power of evolution. The Earth bloomed with life, from the smallest microbes to the largest dinosaurs, and every form of life in between. Evolution was a game of survival, with each species adapting and changing to fit its niche, to outcompete others, to survive. And then, about 2 million years ago, a new creature emerged on the scene, Homo sapiens, us. We were not the strongest nor the fastest, but we had something no other species had, an unprecedented level of intelligence. This intelligence, coupled with our ability to manipulate our environment, propelled us to the top of the food chain. But Earth is not an isolated oasis. It's a tiny speck in the vast cosmic ocean. And the question arises, if life could evolve here, could it evolve elsewhere in the universe? Scientists are on a constant quest to answer this tantalizing question. With every new exoplanet discovered, every signal detected, we inch closer to finding out if we are alone in the universe, or if life is a cosmic imperative, an inevitable outcome of the right conditions. From the Big Bang to the evolution of life on Earth, the universe's journey is a story of creation, destruction, and the endless cycle of life. In the grand scheme of things, we're just a brief chapter in the ongoing saga of the universe. But what a chapter it has been, and what a future it promises to be. Today, the universe continues to expand and evolve. It's an endless cosmic dance, a spectacle of galaxies drifting further and further apart. In this vast and dynamic space, theories about the future of the universe abound. Some scientists suggest the possibility of a big crunch, where the universe could collapse in on itself, rewinding the cosmic clock. On the other hand, there's the big freeze theory. This scenario paints a future where the universe continues to expand until galaxies move so far apart that the stars burn out, leaving a dark, cold cosmos. But remember, these are just theories, and our understanding of the universe is constantly evolving. Every new discovery, every new observation changes the way we see our cosmic neighborhood. It's a journey of exploration where the only constant is change. As we continue to explore the cosmos, who knows what new chapters will add to the universe's epic journey?